Welcome to the video of the presentations of Day 3 of the 2021 MOVES Open House. You can watch the presentations in the order they're presented, or jump ahead to the start time on the right. Thank you for your support of the MOVES Institute. Our first speaker is Dr. Chris Darkin.
I'm calling it Tactical Decision AI Prospectus now. Prospectus meaning just a forward look at what might be coming in the future. And Tactical Decision AI is the kind of AI that I work on. I'll describe very briefly, but I think it's pretty intuitive to most probable listeners to this presentation. You've seen a results-oriented talk already yesterday. This is not going to be another one. That was the talk by Chris Cannon and Stefan Gerke. So hopefully that got you interested in this line of technology if you weren't already. But the issue is, when will this line of research actually impact DoD modeling and simulation? I mean, when will actual people who don't care about AI necessarily, but care about training or analysis or operations actually be impacted potentially by the stuff that we're doing or our students are doing here in MOVES? And I would like to see that happen soon. Next fiscal year isn't too early, I think, for some maybe modest experiments in this direction. I'd like to get moving. So let's spend a little time thinking about so what is this Tactical Decision AI thing, and why would we want it? I think I won't spend much time on that. I kind of assume I'm preaching to the choir on that. Maybe I am, maybe I'm not. A little bit, just enough to motivate the rest about how does it work. Obviously, AI is complicated, but doesn't always have to. There are simple views into what it does as well. And then I'm going to talk about really just one technical obstacle, the main technical obstacle that you have to fight when you work in this field, from my perspective, and what kind of approaches we could leverage, most of which we have not yet tried leveraging in our own research efforts here in MOVES, that might let us succeed and scale things up to where they will be useful for the operational forces. I want to talk about the pros and cons of these approaches, and then just finish with an acknowledgement of the non-technical obstacles which are there, and to, I think, probably again, everyone, we're all here with similar experiences. We probably all realize that you might have good technology, but the reason it's not being used in the Department of Defense has nothing to do with the technology. It has to do with some non-technical obstacle, which is actually the bigger problem to fight. And that may also apply in this case. Let's see what you think. So what I mean by Tactical Decision AI, it's kind of a term I coined, but I think it's very intuitive. I mean AI that makes maneuver and fires decisions. You know, that's it. That's just a small fraction of the ways we're trying to apply AI in the Department of Defense. And even on the battlefield, this leaves out all the psychological factors, which you could, I think, meaningfully argue are the real hard thing to deal with. So this is, in a way, this is kind of the easy version of what's going on the battlefield. We want AI that is kinetically smart, but we don't have it yet. So we're still working on it. Why do we want it? It's intended to be applied as a human behavior model in a simulation. It's that simple. It's going to drive units around in a simulation. Most applications look like that. There are decision support applications for this technology as well, but I think this is the main one. And why do we care about this? Reducing cost, right? Especially reducing cost of training, since that's the biggest budget item. And also increasing accessibility of training, which may be limited. Both may be limited because of the fact that pucksters, which are professional, semi-professional human operators that support a simulation exercise, are relatively expensive and relatively unavailable, depending on where what your position is in the DoD hierarchy. The closer to the top, the less you'll probably worry about this, but for many people, this is a very, very real issue. And finally, we want to think about enabling new capabilities. Not that this is our innovation. These are things people have thought about before, but have not successfully fielded. Like, for example, an automated murder board for operational plans, right? So think of someone who is planning the next day's operations and now inputs it into a system, and the AI says, hey, maybe you don't want to do that because I could do this to you. Okay, that kind of thing. All right. So let's just spend a few words about a topic that I spend 2 quarters teaching to the students, but to motivate what we're going to say later. All these systems under the hood feature very prominently a neural network. Okay, now what's a neural network? Some of you know, some of you, we've all heard the term. What does it really mean? So for now, it's good enough just to think about it as a mapping. It's got an input side and an output side, okay? And the details are determined by many numeric parameters inside the neural network. How many? From dozens to millions, okay? All right, on the input side for our applications, we're going to provide a representation of what's going on in a actual or simulated battlefield. Typically, we're going to provide that as a set of images. For example, one may show where the blue forces are, one may show where the red forces are, one may show where the terrain is slow, etc. Okay, as many as you need. You can, the sky's the limit there. That goes into the neural network on one side, and what comes out? Okay, what comes out is a bunch of numeric outputs, one per action that the system might take. I'm calling it a micro action here, you know, as opposed to like a course of action, which is something we think of as being bigger and more extended in time. So this means just move of 1 unit, whether that be a meter or 10 meters, move 10 meters to the north, okay, a micro action. Shoot this target, not necessarily forever, but for the next minute. Okay, that's the kind of thing I'm talking about. That would be a typical output for this type of neural network. It could be somewhat different, but that's typical. Now, it's a numeric output, so what does the number mean? Okay, each output there is it represents the recommended probability of taking that action in the given situation. Okay, that's at the center of all our, you know, most architectures that are doing similar work to this. It's neural network. It gives you a probability distribution. It says, well, under these circumstances, you should move east 70% of the time, you should move south 20% of the time, and 10% of the time, you should just sit still and shoot, okay? Now, it might not be intuitive to everybody why you want a probability distribution. I'm not gonna get into it in detail, but in general, you do want a probability distribution because being predictable is often fatal in a military situation. So that is really the general way we want to think about generating actions in a stochastic way. So that's the architecture. And what do we do with it? We train it, quote unquote. And what does that mean? Well, we start off with a neural network that has all these numeric parameters inside, and they're just set to random numbers. And since they're set to random numbers, the neural network takes random actions, okay? Literally just kind of staggering around on the simulated battlefield. Okay, now, as this is going on, after each action, the human trainer, or the engineer training the network, arranges for the network to receive a reward. Arranges means maybe he puts this into code, probably, rather than standing there and trying to do it manually, because the system's way too fast for him to keep up, okay? And a reward means what? It's a number that is feedback to the system on the last action that it took, okay? Or at least the last action, okay? So these rewards are most often 0. So most typically no feedback is provided, but if it's something bad happened, then it would be a negative number. Something positive happened, a positive number. If it's better, then maybe more positive, and so forth. So it's pretty intuitive. And the goal is, and what all algorithms that train these networks do, and there's many of them, they have different names like reinforcement learning or things from the game theoretic community. All these algorithms adjust the neural network weights to favor actions that tend to lead to more positive rewards on average, okay? That's the idea. All right, so that's my entire picture of how these systems work, right? If I hand you the neural network, it gives you recommendations and you can drive your forces around the field. So it's gonna tell you what to do in each situation at each unit of time. All right. So the main technical problem that we are facing is simply one of very, very large search spaces, mind-bogglingly large search spaces that are so big that we really can't get our minds around them. You know, I want to say things like, well, they're astronomically large, but in fact, these search spaces may be bigger than the number of atoms in the known universe, okay? So astronomically is, again, just another indication that we as people don't know how to get our minds around these huge search spaces that we have to deal with. Now, this applies both to the set of situations, okay? How many different situations might you be in on a battlefield? Anyone want to put a number on that? Okay, it's huge. and it also applies to the neural network that we're optimizing. How many different ways can we set this? You know, let's be modest. Let's say 10,000 parameters in our neural network. How many different ways can we set them? Well, what are those parameters? They're floating point numbers. Okay, so it's a ridiculous number. All right. These are so big that even with computers being as fast as they are, and even with it being possible to go onto an Amazon or a Microsoft Azure and saying, I've got big pockets, you know, give me 100 of your most powerful servers to go explore this problem, your computation capability is still dwarfed by the search space. Okay. In principle, we would like to look thoroughly at both the set of situations and the set of neural network parameters. And in practice, you're never, ever going to be able to do that. You're going to have a ridiculously small sample, even with all the resources that you possibly could have at your disposal. So just to kind of make sure we're tracking here, let's do a quick reality check of where we are with computation. Okay, so right now, with all the computation we have, we can solve, and when you say you solve a game, that means you can play perfectly under all circumstances. We have solved checkers. We have solved Othello, okay? We do not still have enough even to solve chess. Now the grandmaster, the best player of chess at this moment is a computer, that's for sure, but that doesn't mean chess is solved. Just you can beat us puny old humans, doesn't necessarily mean you're playing perfectly. Chess is certainly not solved. Neither is Go, which is a much worse game to try to solve. It goes double for poker, or StarCraft, or Dota, another video game. And I would say it goes then by the same logic, triple for DoD simulations. Okay, so solving these systems is not a possibility. These spaces are huge, and this has real impacts. So let's now take it one step further and say that actually, given the state of technology, now this is in our hands, but given the state of algorithms that we have, the situation's even worse. And how is it worse? Well, these types of algorithms tend to search for solutions close to where they've had success before, even if it was a very modest success. It did one little thing good, and the systems tend to then gravitate around those modest successes and tend not to do a good job then exploring the whole space, but stay in a very limited region, even though you're giving them a lot of computational resources. Now, in a way, this makes sense because these spaces are so easy to get lost in. It stays where it has success, but this can also be a problem. And another manifestation of a related problem is that they tend to avoid solutions that look like they might be painful. So my way of saying this is that the current reinforcement learning and other algorithms are not fans of the concept of short-term pain for long-term gain. They're really not, in practice, in principle, they should get it, and in practice, they don't get it, okay? Now, why might this be, okay? Well, think about it. So think about just training one unit, one blue force, to go and shoot this one red force on the map. It doesn't get easier than that. So the blue force starts out moving randomly. He's staggering around in a drunken walk. Eventually, he steps up to the red guy. Now, the red guy is just some dumb code, which just says if someone steps next to you, shoot. So he steps next to the red guy, and he gets shot. Okay, and let's say he gets a negative reward for this, i.e. a punishment. Ouch. Okay, and what happens next? If the blue guy would shoot back at the red guy, he might realize that, oh, it was maybe worth it to take that pain. Is that what he's going to do? Well, think about it. There's one way to shoot back. That's one action. There's any number of ways to just move away. Probably he's going to move away. Okay, he's going to move away, rubbing his sore behind, okay, thinking, that sucked. I'm never going to do that again. Moving next to those guys really hurts. Okay, a little bit of personification going on there, but that's really the way it works. And what can happen is that rut gets so big that even later, by luck, when he actually moves next to the red guy and chooses not to move away, but actually shoots him and realizes, oh, this is not so bad. That's actually worthwhile to endure that short-term pain. It can often be not enough to overcome the bad pattern that's already been set. Okay, so bottom line, not only are the search spaces ridiculously huge, but the current generation of algorithms, at least, is not searching them very efficiently. Okay, so that's bad. So what can we do about that? So we're the technologists here, so we can't just throw up our hands. We have to think about some way to get around this. So here is one approach, which is effectively to shrink those spaces that have to be searched. So we can't really shrink them. The neural net is what it is. Battlefield situations are what they are, but we can effectively shrink them, okay? Now, what do I mean by that? Okay, there are exact ways of doing this and heuristic ways. Let's start with exact ways. So exact ways have no downside to them. An exact way to try to shrink the space, to give you an idea of what I mean, is to use symmetry. So what am I talking about? Okay, if I had a map and I put it in front of you and I lay down some red and blue forces, okay, and I show you that and I say, okay, that's one situation, right, everybody? Okay, we all got it? That's one situation. Okay, fine. And then I grab the map and I rotate it 180 degrees around. So what was east is west and west is east. Okay, is it the same situation? Every human knows, of course, that's the same situation. It doesn't matter just that because you rotated the map. And every AI will look at it and say, oh, this is a completely new situation. I've never seen this before. It might be the world's expert on the first situation, but it has no idea about the second one. Okay, this is what I'm talking about. Now, symmetry exploitation is a thing in AI. Okay, so maybe it's not literally every AI that would have the problem, but in practical terms, yeah, every AI, certainly everyone coming out of my lab. I don't know anyone who's doing a much better job at this point in time, but clearly we could do a better job. All right, and there would be no downsides to that, okay? Effectively, if you realize that just flipping things by 180 degrees doesn't change anything, what have you done to the size of your search space? You have the effective number of situations, of battlefield situations, okay? That's the idea, and this is not the only symmetry. There are many other symmetries that can be applied. So this can help. It does not completely solve the problem, but it can help, and there's no downside to doing it other than some hard work up front. Now, there are also heuristic ways to effectively shrink the space, okay? One is that you kind of cheat, just change the game, okay? In other words, you constrain actions with code. So you limit the amount of action selection you expect from the neural net. So if I see my AI just spending ridiculous amounts of time staggering around and never finding the enemy, then I might say, well, you know what? I'm just going to hard code it. So the AI just kind of moves beelines up close to the enemy, and then I'll let the neural net take over at that point. That will effectively shrink the search space. Okay, you also do things like what I'm calling like a due diligence kind of heuristic, right? So if you're making an AI that's doing assault planning, you might force a unit that's moving to consider specific trajectories that you consider interesting, right? Like you may have some other code which finds all the main mobility corridors for the specific terrain, and then you force the AI to try all of them to make sure it's not getting stuck in some specific rut. These things could certainly be done. Are they normally being done today? No, certainly not in my lab, and only to a very limited extent in other places. Okay, the second notion is, okay, never mind shrinking the search space. We'll leave it big, but we'll provide some guideposts for the search. Okay, and there's many ways to do this. Let me give you a notion of some of them. So there's a thing called imitation learning in AI research. And what do they mean by that? It's just kind of like what it sounds like. Okay, you copy the performance either of a person or of the strongest existing AI that you can, at least to get started. Okay, this can help. Okay, there's a notion of curriculum learning. I talked about the MOVES curriculum a couple of days ago. This is a similar idea. Basically, you build a sequence of tasks, easy to hard, and you let your AI learn the tasks in that order while maintaining what you learned from previous tasks, which is easy to say and harder to do. Okay, so for example, you could first learn to approach the enemy, and then you could have a separate task, completely separate. Don't worry about approaching. Now I'll put you right up next to the enemy. Just learn to fix it with fires. Okay, and now I'll have a task where you're up there and you just do the assault, and then only then will I expect the AI to try to learn all three. Okay, and last but not least, and this you saw happening if you paid attention or if you heard Chris and Stefan's talk yesterday, you can give rewards. You can do what's called reward shaping. So this is a term, if you know animal training language, then you know this term, okay? It's basically giving rewards for baby steps, for things that you actually don't want to, like, if you'd want to train your dog to sit and it's a new puppy and you say sit and he moves his butt a little toward the ground, you're like, hey, good boy, have a cookie. It's not because you want him to wiggle his butt. What you actually did is not what you want, okay? But it's motion on the way to what you do want, okay? So you give rewards now for those baby steps and you will withhold them later when you raise the standard for performance, okay? So you should recognize these. I mean, we use these exact same strategies to train people. So it's really kind of fun for me that we've come to the point as a field in AI when what we do with the AI systems is now very recognizable if you are familiar with training people. Okay, I see things stacking up in the chat. Hopefully someone's tracking that. And I'm going to try to wrap up quickly here. Maybe we can handle a question or two, and I will try to get the rest offline if there are questions rather than comments.
Yeah, Chris, I am tracking the chat, and I don't think there's anything we need to break into right now.
Okay, good. I want to stay on schedule. I think that's important for an online event. Okay, so let's talk about pros and cons now of these techniques. These are all techniques which everything I've mentioned has certain merit. I would certainly not disdain to apply any of those things, even though we have not applied them yet. Okay, now pros are that well, here's a pro for you. It just may be necessary. It may be flat out necessary to get an AI that actually carries out your task at all, to any degree of goodness, not to mention to perfection, okay? That's a pretty good pro, so I'll leave it at that. Now, there's also cons, though, all right? All of these techniques I described, basically, we're taking our biases, our human biases about the domain, and we're foisting them off on the AI. This might be okay, and I think for many applications in DoD, we want the AI to follow our doctrine. Okay, then doctrine is a kind of a bias. It's a bias as to what is right and what is good to do in a certain situation. In that case, it's fine. No objection to it. But it can be terrible if what you're trying to do is get the AI to find innovative courses of action, right? The kind of the murder board idea. And that's where we started with this thread of research in moves. And so that's why, like the work you saw yesterday, did very little beyond a little reward shaping to apply these techniques, because they all involve biases, okay? And the thing to really watch out for is that, and I do think this happens in AI. I'm not just being extreme here. I think you can take these techniques to ludicrous extremes, okay? Where you really end up building a scripted AI by other means, okay? This is my language here. Scripting by other means, okay? You know what a scripted AI is? It's where you just hard code something simple in, okay? So if you imagine an AI and it's not doing the right thing, he should move to the north and attack that unit. So you say, okay, I'll give you a reward for taking 1 step north. Okay, I'll give you another reward if you take 2 steps. I'll give you another reward for 3 steps. I'll give you another reward when you shoot for the guy. Well, what are you doing? You're taking the AI by the hand and you're moving it through the whole sequence. You might just as well have scripted that, except that you can say you used cool AI tech to produce your behavior, and you spent more money and made it a lot more complex than it needed to be. Okay, that's not where we want to be. Okay, that's the situation here. I wanted AI, but what I got was just plain old I. Nothing wrong with plain old human intelligence in many circumstances, but not when we're paying to try to get AI for good and sufficient reasons. Okay, all right. Now, last, let me just acknowledge some of the non-technical obstacles that we are facing here, and these are very real. Starting from the fact that an interface which will let us connect our AI tech to a DoD simulation either may not exist at all or may be inadequate. Now, this is just a cost issue. It's not rocket science to solve that. It just requires money and it requires will. But so far, it's been somewhat lacking. Now, we're just seeing some progress in this area for some simulations. OneSAF in particular, I think, gets a little bit of credit in this regard. We hope to leverage that in some work coming up soon. Okay, secondly, the right sim for a given task, or even for a given same task, but a given customer may be different from what you've used before, okay? And that may just be a cost issue. You have to redo work. Or it could be that you just can't find a sim which pleases your customer at all. Now that might be, again, for good reasons, because the customer actually is right. There is no sim that actually is going to scratch his itch. Or it can be a cultural issue, that the customer just doesn't understand the simulation tech or has some other more irrational bias that could be overcome with time and education. Okay. Last, but still very significant, is that the quantitative assessment of behavior, which we rely on to build these AIs, we need to give numeric rewards to this system. We have to be very specific about how much we like behaviors and how much we like each behavior. We don't really have the culture to do that inside DoD. Now, we have more of the culture of, are you capable in that area? Let's test your unit out. Okay, you're capable, check. Okay, right? That's really where we are on most things. Not necessarily everything, but most things. And if we want to decide whether behavior is good in other contexts, we don't even do a check up or down, right? We do a war game exercise, and we don't say if the behavior was right or wrong. Our attitude is, well, as human beings, we're trying to learn. We're getting new considerations in our head. We hopefully advance our thinking and get more prepared for other exercises and real operations in the future. That's where we are in our culture. But to really get juice out of some of these AI technologies, we need to think hard about what stuff we can code into a hard quantitative framework, because that is really required. Okay, I'm sorry, I'm talking through all my stuff. I will answer things in the chat, so get ready for some typing after that. I still want to do this. Okay, just for fun. Let's consider this, all right? So Alphastar, that was the big system that DeepMind came out. StarCraft, if you don't know it, looks very much like a constructive simulation. They built an AI that could be 98% plus of all human behavior. So where's DoD's Alphastar now? That's been a couple of years, okay? They published their results. Okay, why don't we have it? All right, let's talk about all the reasons why we don't have it. Starting from StarCraft, it's close to a constructive sim, but it's definitely not the same, okay? So it's not a matter of just directly dragging the AI over. Secondly, Alphastar used a huge amount of imitation learning. They took years of top expert play, and if you don't realize, in video games has real experts. There are people that just play them all day for money. They are real experts in video games. They took all kinds of expert human data and used that to bootstrap the system. We just don't have that in DoD for most applications. Probably that's being too generous. Probably for all applications. Let me go out on a limb there. Okay. Next, the cost in computer time to train Alphastar is not going to work for most DoD budgets. Okay, so one blogger I read this morning estimates that just to do the final training of Alphastar, after they perfected the system, which is where most of the cost would be and most of the training would be, just to do the final build required $13 million of computer time. Okay, if you've got a budget like that to play with, I want to talk to you. Okay, that's not normal for most DoD applications. Next, it's not a matter of just grabbing Alphastar, even though it's different, and then we have to adapt it to a constructive sim. Okay, the source code is not available. Okay, now they did, however, publish the architecture, but hold on to your seat when you open that up. It says if you look at their Nature paper and you download the digital annexes, you will get pseudocode for their architecture. It is extremely, extremely complex, much more so than anything we've tried in this area in DoD. So now, with no time on the clock, I've made it to the end. Well, at least I've done that well. So thanks very much for your attention, and I apologize for using all the time. I'll try to get back to you in the chat.
Actually, we do have some time for some questions. I put the breaks in mainly to allow us to kind of run over if necessary. So I don't think—
Okay, if there are important ones, you got to call them out. I don't read this fast. It'll take me a while to get through the
going
chat.
through right now. I think the first one was John Richardson from NIWIC mentioned that if training sets can vary geometrically, you can try Euclidean 3D neural nets to reduce the complexity, but not the training results. And he published a web page, or Byron Harder hopped in and published a web page about that. So everybody can check that out in the comments there. That's a little bit on that. He said, it seems to be a rotation in variant molecular bias sets are an example. I'm not even going to try to interpret that because I don't know. If John, if you want to pop in.
Yeah, I'll take a look. I will take a look at that. That's interesting. Yeah, I'm looking for good ways to implement symmetry. Honestly, the like I said, not a lot has been done with this, and if stuff is done, let's take a look at the Go work that DeepMind did. Okay, they're pretty top notch. What did they do? They did not try to build the symmetry into the structure of the neural net. What they did is they simply took every training position, every board position, and just said, well, let's just rotate it every possible way. And of course, also flip it, right? So flipping the board upside down for Go is also a valid Go board. Okay, so from every single Go board, every single training example becomes 8 training examples, and hopefully you get to a system with a good approximation of rotation and variance. That's the state of the art, and this new thing sounds interesting. I would like to learn more about it.
Excellent. Yeah, and John mentioned also that there is a NAVCATA conference, the Naval Applications of Machine Learning. The proceedings are available, and Don put the link to that. Don Brutzman put the link to that in the chat. So that's available in there also for everybody else. And then Rick Lentz put a link to the DARPA Game Breaker program, which is, dealing with what you were talking about at the last part of your talk, with basically applying AI to break video games. I didn't have a chance to get too much information on that, but if you're interested in that kind of thing, that may be a really good place to look for that.
Yeah, I would also mention, though I don't know of a single page out there that describes it, but maybe one's surfaced, the DARPA Combat Program, which is specifically trying to build Red Force AIs for the Army. You might also be interested in finding out about that. Certainly you can do it informally if they haven't published things. At last I checked, nothing was published beyond the BAA. That's a running program. Okay,
excellent. So that takes care of all the, I think all the questions in the chat. If I missed one, somebody please chime in if I missed yours. But does anybody have another question, either that comes out of something we discussed in the chat or something from another part of the talk?
Okay, I'll send the slides to Perry. So if you have questions occur to you later, my email is not actually in the talk, but I'm easy to find. Just Google me.
Excellent. Okay, I have no further questions. Thank you very much, Chris. That was an awesome talk. Really appreciate that. It's really, it's always good to hear the great stuff that you're working on there. Okay, our next speaker is Dr. Kurt Blaise, and I highlight doctor because during the last Moves Open House, I don't think you were Dr. Kurt Blaise. You were just plain old Mr. Kurt. So it's great to see that you've earned your doctorate and moved on with that. And you're going to kind of be presenting a lot of the subject you were, the subject of your dissertation. And I think yours is called Interoperability, the whole enchilada. So I think that'll be another great talk. So Kurt, please take it away. I can see your screen.
You got the screen? Okay, I'm going to go to slide mode, so hopefully everything will stay up there, but I won't see chat and such. Come on. There we go.
Yep, looks good. All
right, thank you. So yes, I want to talk about the whole enchilada today in a couple different perspectives. I don't want to talk about interoperability just at a single system to system kind of perspective, like we've even seen in some of the talks the last couple days. But I'd like us to, let's see what the whole elephant looks like, for better or for worse. So here it is, here's the whole enchilada, but apologies to the restaurant chain by the same name. So I don't really have that in there for any particular use, although it's a nice graphic. It's really more of a nod to my duty station, which is Las Cruces, New Mexico. So here's a view of the city down in there in the valley. We do get winter, a little bit anyway, so we get a smattering of snow in the winter time. But we do get some really great sunrises and sunsets. So it's nice living in the desert. I'm going to be talking a little bit about statement of the problem. I'll give you a chart that talks about levels of interoperability. I won't spend a lot of time on that. Many of you have probably run into that before. It's been around for a number of years, but it gives us some terminology that we can use in our discussion. I'll be looking at the scope of the problem. Now, I said it's the whole enchilada, but when it comes to actually giving some examples, we'll be looking at some particular areas. And ones that I'm very interested in are interoperability across command and control systems and simulation systems, as well as adding in robotic and autonomous systems to that mix. So we'll talk a little bit about those just to help us understand the nature of the problem even more. And then we'll get into some elements of a solution. There is an international standard out there called C2SIM. I'll spell out that acronym a little later. And there's some activity going on in the NATO community of which you might recall that United States is a member. So we will become part of that activity. In fact, we are part of that activity. But it's a bit different than what we see happening in the United States across our Department of Defense. So it'll be interesting to watch, and maybe it'll be the key to solutions for us. And that's called the Federated Mission Networking Initiative. So here we go, statement of the problem. I hope some of this is a little stimulating and provocative even. So we in the US DoD do not have interoperable systems by design. We can achieve, and we often do, some level of interoperability, but it takes effort. Effort, of course, translates to money. We spend a lot of money getting systems to interact with each other, what I call after the fact, well after sometimes well after the systems were developed. Now, this is the amazing thing to me, as I've thought about this for a few decades. Interoperability never needed to be a problem. Right now, we consider it a pain point, a problem, a challenge, et cetera. It never needed to be that. Achieving interoperability at an architectural level is straightforward. Achieving interoperability after the fact is hard to nigh unto impossible. So a corollary there is that it's technically possible to make interoperability considered as a problem go away. And we'll have opportunity, I'm sure, maybe the chat line is lighting up right now, I don't know, but we won't open up the mics yet. But we can talk more about this as we go along, or a little bit later. But let me just leave you at that. I think it's feasible that interoperability can go away, that it doesn't need to be a problem, but it will take some tremendous resolve to make that happen. We'll talk a little bit more about that later. So again, I wanted to introduce this levels of interoperability, or maybe for many of you, just a reminder of these concepts. It's been out since about 2003. Tolkien McGuire wrote a paper describing this, and the model has changed a little bit over the years, but the idea is generally the same. There are systems that don't need to talk to each other. That's level 0. There's no interoperability there. Level 1 interoperability, what they call technical interoperability, we're able to exchange information. Now, we may not care yet so much what's the nature of that information, how to parse it, whatever, but we can move the bits. Syntactic interoperability now gets a little more precise, that we're able to break those bit streams down into some identifiable pieces of information. And we have assurance because each partner in the interaction is using the same syntactic representation. We have some assurance that they are pulling data out of the bit stream in the same way. Next level up, semantic interoperability, is a little bit beyond that. Not only are we parsing information consistently, but we're also interpreting that information consistently. And one of the things that is kind of lacking today is that we don't have any assurance that two systems talking to each other are interpreting the information in the same way, because we don't know for sure that they're using the exact same data model in the same way. Pragmatic interoperability goes into, once we've got the information that we've pulled out of the bit streams, how are we actually manipulating it? What kind of processing are we doing with it? Can we assure that two systems are doing the same kind of processing on that information? And then these other levels, dynamic and conceptual interoperability, are still kind of out there as research targets. Certainly would like to achieve those levels, but I'm pretty happy right now to be concentrating at the semantic and pragmatic levels. There's enough challenges there to last for a while. So here's scope of the problem. And I consider this to be kind of a partial scope in that you could add in some other systems here, combat systems, weapon systems. So this could become more complicated just in its simplistic form here. But let me start at least with these classes of systems, which represent a pretty significant number of systems in military operations. Command and control systems, of course, simulation systems, and again, robotic and autonomous systems. Now, even this simple diagram is kind of deceptively simple, I suppose, because we've got those little loops on each box, which means we're also interested in interactions that happen among C2 systems, heterogeneous C2 systems. Okay, so there are many of those. Robotic and autonomous systems, there are increasingly more and more of those entering into service. And those need to talk to each other. Those are heterogeneous systems. And simulation systems, where we've probably spent most of our time in this community, modeling and simulation community, we already know we have several different or heterogeneous frameworks for interoperability just in the simulation system box. We have high-level architecture, distributed interactive simulation, test and training enabling architecture, and so on. So we've got a lot of different kinds of connections going on here, and many, many, many different ways that those have been addressed. And we'll look at, again, some of those in the next couple slides. But let me just pause for a moment, though, to say, let's not be too hard on ourselves here, because when you stop and think about it, we've only been at some of these things for no more than about 35 years. Okay, now for some of you, maybe 35 years seems like a long time. For old people like me, 35 years, is not that long. It wasn't that long ago, you might recall, especially NPS folks, having simulations interact with each other through the SimNet work in the late 80s was kind of one of the first breakthroughs in that area. And that led to the Distributed Interactive Simulation, or DIS, standard some years later. Which followed on with HLA. HLA is only just over 20 years old. C2 systems, tying C2 systems to simulation systems really started becoming a thing in the early to mid 90s. And of course, throwing robotic and autonomous systems into this mix is very, very recent. Within the last 10 to 15 years, where we've started to get serious about it. So, okay, from that perspective, maybe it's okay that we are, just scratching the surface on these things. But I would have to question the way that we're doing that. And at what point do we stop scratching the surface and decide to just solve the problem, make interoperability go away as a problem? Okay, so let's just look at the C2 and simulation arena for a minute. And you're probably quite familiar with these ideas. There are reasons why we want to be able to have command and control systems and simulation systems exchange information and work together. Train as you fight is one of the most common reasons. We want to be able to tie live C2 systems with our virtual or constructive simulation systems to create meaningful training environments and realistic training environments. Of course, there's system test and evaluation. If you have a new command and control system and you want to try it out, you need to stimulate it with something. Generally, that's through simulation. Post-exercise analysis and instruction. Operations planning. This is interesting because Dr. Darkin just brought this up in his presentation a little bit ago. You know, one of the reasons people are looking at artificial intelligence, machine learning, is to try to improve the capability to use simulation to help in military decision-making process. Things like course of action evaluation. Operations rehearsal, exploration and replanning even during operations has been explored a bit, but is still very much in its infancy. Post-operations analysis. Matter of fact, just as a side comment, I suppose, we are in the midst today of a pretty interesting email thread with the Army that is addressing exactly these issues of integration of simulation with command and control for improving the military decision-making process and even doing exploration replanning during operations. So though it's been around for 20, 25 years, we still have a long way to go in that area. Now, you know, what's kind of prevented us in the last 20, 25 years of making significant progress just in this one realm of command and control to simulation system interoperability? Well, some of it, quite frankly, has been socio-political. The two communities have worked quite separately for a long, long time, back into the 70s. Can't go much earlier than that because much before that, we weren't working with computer-based training systems and computer-based command and control systems. So those communities have been kind of separate to some extent at cross purposes. They certainly haven't been integrated throughout the history of this process. Different data representations, fidelity, precision, content, purpose. There are aspects of that that make it challenging. Different timescales, simulations often can run faster or slower than real-time. Command and control with the human in the loop obviously is operating largely at real time. There are occasions where you could be working in a situation like for planning, where you may have a simulation move forward at faster than real time in order to reach kind of the next stage of an operation that you're looking at. Different execution frameworks. Command and control systems have largely used things like operational message formats and such. They've run standalone and federated, just a lot of different and kind of cross purposes for the various systems. In terms of exchanging information, there have been many, many ways to do it. Shared data, DARPA had this Deep Green program over the last 15 years. If anybody has information on results or products out of Deep Green, please contact us. We'd love to hear about that. I haven't heard anything out of that program for a couple years. The NATO community has used what's called multilateral interoperability program. They're using replicated databases that are maintained across a number of systems and across countries. Tactical message formats. Here's just a smattering of some. There are many, many more. There are message exchange frameworks. The Navy has this architecture management integration environment, or AMI, that is used in a lot of its synthetic training environments. There are command and control to simulation interface languages. The Coalition Battle Management Language was an earlier standard about 8 years ago. Broader data exchange languages, there's the National Information Exchange model that's even meant for interchange across departments of government, Department of Justice, Department of State, Department of Defense, and so forth. So suffice it to say, there are many, many, many different ways of getting the job done, which of course contributes to the whole interoperability problem. In the area of robotic and autonomous systems, very new that this has become a major area of concern. Obviously, extensive R&D and operational employment. I don't hear people talking about offset strategy anymore, but it was certainly seen as that a few years ago. Introduces many different information interchange approaches. There are different levels of commanding robotic and autonomous systems, whether you do it at a very, very low level of detail or at a more abstract level. MOVES has been involved in these areas for over 20 years now, actually. Autonomous unmanned vehicle workbench, autonomous vehicle control language have been some major areas of research. NPS, of course, is very active in robotics research through this Cruiser program. In terms of robotic and autonomous system interoperability efforts, and the asterisk there at the bottom tells you this is just illustrative, far from being exhaustive. But just, if we just take a look at some of the things going on in the US military today. Naval runs a program where they're developing what's called Naval Interoperability Profiles for dealing with unmanned aerial systems. And they've developed these NIOPs, Naval Interoperability Profiles. They've developed them for command and control and tracks and some other areas, imagery. So that's one area. And one of the things they're doing, actually what the profiles are, is just identification of certain standards. For example, in the tracks profile, they have identified the NATO standard 4676 STANAG for track information, which is great because of course that gets us in concert with NATO operations. PMS 406 has this unmanned maritime autonomy architecture, less than about 5 years old. They have a common control system and certain ways that they're specifying for controlling unmanned systems. Oh, but the Air Force has their open architecture management, universal command and control interface, or UCI. These two things aren't the same. So we still have kind of a hole between trying to get Navy and Air Force to talk together with respect to unmanned systems. Oh, but let's throw in the Army. They have their own approach too. Their MUM-T family of systems. They have a protocol interoperability profile. So, in recent years, with the addition of RAS into the mix, we are finding ways to expand the challenges and problems of interoperability rather than trying to solve them in the early stages. So let's talk elements of a solution. The Simulation Interoperability Standards Organization, or CISO, last year approved a new standard for information exchange called C2SIM, or C2 Systems Simulation Systems Interoperation. I give you some links there if you want to go find additional information on that. But the purpose of that standard is specifically to look at the exchange of plans, orders, and reports across command and control systems, simulation systems, and robotic and autonomous systems. So today, C2SIM is the only international standard addressing that breadth of interoperability or information exchange. but plans, orders, and reports actually constitutes a pretty significant chunk of information that we want to be able to share across systems. So C2SIM is an element of a solution. It is a common approach that people can start adopting. It covers tasking, reporting, initialization, as I mentioned, plans and orders. It's really focused down in the very last bullet. It's really focused on the semantic level of interoperability. So it has a formalized information model that people can implement. Now, as far as the key initiative to watch, this NATO Federated Mission Networking, this is a multi-year program. They are doing this through multiple 3-year, what they call spirals. I consider the overall thing kind of to be a mix of, spiral methodology and agile methodology. If you look inside each spiral, it looks a lot like agile development. So Federated Mission Networking is the way that forces would come together and connect rapidly to provide operational effectiveness in the conduct of a coalition mission. Now, this is pretty important to us in the US because if you look back in recent history, coalition operations are pretty prominent these days in terms of major operations that we perform. And so some of the objectives of the program are identified in the bullets there. The key one for us is this day zero interoperability concept. In other words, you bring your systems, you plug them together, and they work. So elements of a solution, back to our big picture diagram, so to speak, that was still partial, but certainly covers a lot of territory. C2 vision is that we see a day when we can bring systems together, turn them on, authenticate, they interoperate, they pass information back and forth, and then we have, again, some assurance that the information is being used consistently across that whole coalition of systems. And then the key one for the Federated Mission Networking is that goal of day zero interoperability. Now, I happen to be a proponent of C2SIM. I was involved in that standardization effort, so I'm excited about it. Is it something that the United States will adopt and say, oh, we need to use that across all of our systems and across all of our services? I would certainly like to see that happen, but we are a long way from that. As I say in some concluding remarks, we've got a choice. We're sort of at this threshold, right? We can continue to diverge technically at great cost and at growing cost, right? Because we keep building these interoperable solutions over and over again and add to them rather than fixing it up front. We can keep doing that until funding constraints cause us to stop going down that path. Now, understand something. NATO already faces funding constraints. The reason they try to bring everybody together and have this huge cooperative effort is because they don't have the money to go 50, 100, 500 different directions, okay? I suppose one of the failings we have in the US is due to our great success. We have lots of money to spend in lots of diverse ways that don't necessarily take us to a long-term solution. So we can either do that, continue to diverge, or we can work seriously on common solutions. Now, seriously is going to go beyond, or when I say seriously, it goes beyond one group in one part of the Navy saying, here's the way we're going to do it. It's got to be much broader than that. for us to move down that path, as I say here, we would truly need to buck historical precedents and the hyper independence that we enjoy in some sense in our system developments. So interoperability as a problem can go away. Technically, it's solvable, but we've got to have the fortitude and determination to make it happen, which is going to take tremendous resolve, at very high levels. It's going to involve putting the money where our concepts and goals are, and making it happen. And let me try to maybe catch this criticism before we even get into the question and discussion. Some say, well, the standards that are out there just don't work for us, so we need to create something new. I mean, we do that all the time, right? The way we need to rethink that is, if the standard doesn't work for us in a certain area, then let's get back into that standards community and make it work. HLA had that funny problem of, you can't have two different HLA implementations work with each other over the wire. That was kind of unfortunate. At least, they've been able to find a way through the real-time platform reference federated object model. They've found ways to, pretty directly integrate DIS with HLA. So that's nice. But, when HLA was standardized, could it have had multiple modes of operation where, DIS, TINA, whatever, any of these other requirements could have been met? Sure, if we would work together rather than creating something new. So I'll leave it with that. I just think it's fascinating that the New Mexico sunrises have the same color scheme as red chili enchiladas. So that's a philosophical thing for you to ponder. But that's it. I might have stayed in time, but I started late. So
don't worry about that at all, Kurt.
Sure.
You did great. So looking at the chat, there were a couple of websites posted. John Richardson posted the CISO standards website. Don Brutzman came in with the NATO Federated Mission website, as well as the wiki page on that. And let's see, one comment from John Richardson is that, I think Don's trying to get in. So Don, do you have something you would like to add?
You're muted, Don.
You're muted, Don.
Yes, thanks. Just standing ovation, Kurt, on pointing everybody at the right problem. And I hope it's maybe not as hard as you make it sound. I'm very optimistic about our work we described on Tuesday about data. Getting data standards aligned could be a way for these systems to communicate without changing the systems themselves. And your central role in C2SIM is hugely important. And unless anybody thinks this is merely a noble endeavor, I can think of two national adversaries who are no doubt very, very happy that our modeling and simulation capabilities do not inform warfighting, command and control on a daily basis. So if that's not enough imperative for people, okay. Kurt, thank you.
Thanks.
Excellent. And then John Richardson also had a comment that NASA likes HLA for astrosims in the US, European Space Agency, even the Russians and other space agencies seem to use that. So I wasn't aware of that. So it's an interesting thing to pop in. The other things.
That's true. Actually, let me just add to that for a moment, because CISO is also developing a space federated or federation object model standard. So
excellent.
Agree. Yeah.
Good. So let's see if there are any other questions or comments for Kurt. Okay, so then the only other comments in there were Don was so enamored with your enchilada that he posted a link saying that he liked enchiladas, and then a link to the whole enchilada restaurant in Moss Landing. And I came back and I said, well, if I'm going to Moss Landing, I generally go to Phil's.
Right.
There. And Bill Mahan piped in to say he really likes both of them. And, that was kind of a little lightheartedness, but it's also serious in that hopefully next year, we won't be constrained by COVID as we were this year, and we will be able to have an open house in Monterey. And those of you who aren't here will be able to make it here and try, those are two of the good restaurants in the area, but there are just a ton of restaurants out here. That's 20 minutes north, 10 minutes south is Carmel. And, you can come officially for, all the, the great lectures and everything. And the one thing that we are missing here is there's no real good way to get together and have the conversations in the hallway during the break, where I think everybody agrees that a lot of the best work in a conference comes from. But, hopefully we'll be able to get that next year. So please try to put that on your calendar. It will likely be the week before Memorial Day again. That's traditional time. And we should have more information by Itzik about Moves Open House 2022. And speaking of those breaks, it's time for another break.
Thank you.
Yeah, so sorry, I didn't say thanks. Thank you, Kurt, for a great presentation. That was really good. And again, congratulations for completing your doctorate since the last time we saw you at the open house.
I'm Perry McDowell.
Thank you.
I'm going to brief on a program of outreach support that we received from the Office of Naval Research. And Dr. Quinn Kennedy is my co-PI on this. The background is that the Marine Corps educates its modeling and simulation officers, 8825 MOS at the MOVES Institute, Naval Postgraduate School, and many do theses in the area of human performance, training, and education. I think, that's probably not a surprise to anybody who's been here for the past couple of days. But ONR used to have a branch called Code 30 that they did away with about a year or so ago that was primarily supporting expeditionary warfare, which is essentially the Marine Corps within the naval services. And the HPT&E area used to be inside Code 30. They did away with Code 30, and now it sits in Code 34, which is really the human performance area. But it was originated there. They say, we'll have these M&Fs officers, many of whom are highly involved in the training systems that the Marine Corps has and uses, and they'll be involved in making decisions on them. So it was a good way for ONR to provide some educational funding to ensure that these officers could do a little bit higher quality theses if they needed the funding to have a little more opportunities to do their research that way. So the goal of this is basically to support M&S research initiatives of our current 8825 Marine Corps students. Because it's the Office of Naval Research, we've kind of expanded that to include Navy students or other students from other services if they're doing a thesis that directly impinges upon one of the HPT&E areas that Dr. Peter Squire, who's the program manager for that area, that he supports. We also want to get a collaboration and discussion across the modeling and simulation community of interest and figure out what type of research will really help out the Marine Corps and the community at large. And finally, we want to give the students some experience in running research and programming teams that they may not be able to do otherwise without having the funding involved. So for those of you who don't really know what ONR is the Naval Research Enterprise. It consists primarily of the ONR headquarters, which is in Arlington, Virginia, ONR Global, which is in London, England, and the Naval Research Laboratory, which is on the Potomac River just outside of DC there. And there's 4,000 people involved in it, 23 different locations that they kind of consider their main locations, not just areas where they're doing, where researchers work. $2.5 billion per year, and they have more than 1,000 partners, i.e. those are people that they're actually funding to do research on or they're working with in their research area. And their research studies almost every area that can affect the future of the naval services, the Navy and Marine Corps. And what's interesting is this is one of their main pages they have here. Is if you look at these pictures here, there's at least 1, 2, 3, 4, 5 that really kind of maybe the fifth one doesn't per se, but really kind of come down to you definitely say, yeah, that's the kind of work that Moves is working on, or similar to work we're doing. So there's a great symbiosis between ONR and Moves. We're very worried about a lot of the same problems. And so Code 34, the Warfighter Performance Department, is designed to enhance warfighter effectiveness, basically through manpower, personnel training, system design. And basically they're trying to make sure the person gets the right information at the right time and has the right skills to do the right job. And as I said, Quinn Kennedy is my co-PI on this, and we get funds each year to support the theses that support that. The human performance training and education vision really comes down to the idea of small unit leader dominance. There's a lot of things to do with human that you could, at ONR, that you could say, would fall under human performance training and education, but they're really trying to hit the idea of small unit dominance. And, they want to make sure that the small unit leaders are really able to go out there and make the correct decision at the correct time. When Max Schessel gave his talk yesterday, he pointed out that I think it was like 78% of the Marine Corps were E1 to E3s, or maybe that was enlisted. I can't remember the exact thing, but very low-level people at the, and these are the small unit leaders. We're talking about the lance corporals, sergeants, all the way up to the second lieutenant in charge of his platoon. That they're really looking at trying to give them the advantages. So when they're going into combat, it's not a fair fight. We never want to be in a fair fight with our enemies. We want to make sure that we've got a huge advantage going into it. So their technical investment areas, they have 3 areas they work in primarily that they're trying to work in, that they focus their research on right now. And they're actually kind of moved to a 4th that I'll talk about in a second. But the 3 that they've had that are the traditional areas are decision-making and expertise development, or DMED. And that's the area that we primarily work in. There's warfighter resilience. Warfighter resilience is really kind of physiological or mental, basically trying to help out the warfighter in those areas. We don't do as much research in that area, although a few years ago we had a Marine Corps major, Erin Demschko, who was very interested in that, and her thesis dealt primarily in the warfighter resilience area. Then the other idea is augmented warfighter operations. This is basically helping the warfighter out by giving them computers or information in a way. A lot of it involves augmented reality, so that they can basically have a huge advantage over their adversaries when they're out there in the field fighting the wars. And to kind of break these down a little bit more, DMED is, I won't read that to you, but they've got 4 sub-TIAs that they work on there. One is tailored training. That's kind of the idea that, traditionally the military has given you the same training regardless of where you are. So if you're at this point in your career, you're a sergeant, you'll get the same training as all the other sergeants going to the same type of job. And you may have done similar job before, or you may be sitting next to somebody who's never done a job before. In class, technically they'll give you the same training going through that. They're trying to avoid that so that the training you're getting is actually the training you need. One of the ways, we always talk about things when you actually go out and exercise, either in the real world or in a virtual world, it's very important that you have an after-action review, or else you're just running around there, playing soldier out in the field. And there's quite a bit of research area in the idea of how to assess people as they're going through training, and how to provide after-action reviews later on. And they're doing this both in a virtual space, which is fairly easy, which is easier, let's put it that way, or in a live space, which is much more complicated than doing it in the virtual space, because you have to go out there and get the information of what live people are doing running around. I have another TIA about terrain generation and simulation enablers. Notice terrain generation is crossed out. That's because it's been moved into a new area. I'll talk about that in a second. Simulation enablers are basically the things to allow you to build simulations quickly. and easily. It's one thing that, if we can sit here in a sim center or in a lab and build a great simulation, what the Marine Corps wants to do, and Peter Squire within his area of research wants to create tools that will allow the simulation being used by Marines actually out there in the field. And there's the fourth TIA, that's the educational outreach, that basically is what we're funded under. I won't go into warfighter resilience or warrior resilience too much, but the augmented warfighter operations is another one of their TIAs, and they're looking at visualizations and interaction. Basically, if I have time, I'll show a video of one of their warfighter augmented reality system that basically is designed to help out a JTAC in the field, and it really provides a lot more information and kind of reduces the load on the JTAC, the mental load that they're performing out there. Looking at the different component technologies that come together to make that, as well as human-machine teaming, those are two really big areas that we're working on. We've done a lot of theses in these areas recently, and so it's very, very big area there. And actually get into decision sciences and tools, how people are making the decisions out in the field, and what tools we can give them to basically allow them to make the correct decision and what larger percentage of the time, or get them, goes back to the idea of making sure they're getting the right information at the right time to the right person. They just started up a new area for Peter Squire, because I guess his research is doing fairly well. They're calling it Program 42. And that's not for Jackie Robinson. That's actually for, it's a Hitchhiker's Guide to the Galaxy reference, where 42 was the answer to everything in the universe. And they're coming up with the idea of tactical Marine Corps. And I mentioned that terrain generation has moved out of the DMED TIA. And that's because it's so much of that is now AI that they're actually putting it together within the tactical AI world. So this is a great area for us. We do quite a lot of AI. You saw Chris Darkin's work there this morning, and it's a great area for research in here. A lot of the similar things that Chris is looking at is what the researchers working for Peter Squire are working at, kind of coming down to how do you do a mission, how to assess a mission, figure out that sort of thing, what you think the enemy is going to do, how to communicate, make sure you're setting up communications correctly. And then as you see, terrain generation added there on the fifth one. So basically, this is just one way to help out with the Marine Corps planning process as people are going through that. I think this is going to be very, very useful for that area in the future. So he's been funding this he's basically shifted some of the things he's been funding into this area, but it's going to be another area of emphasis for him in the future. I'm showing this slide, and this is one of the slides that Peter Squire showed during his technical review in the spring. And he really had about 4 or 5 of these for each of the technical interface areas. And the reason I'm showing this, though, is not necessarily to talk about all the different things they've done, but show the breadth of kind of what they're looking for. And what's interesting is that if you look here, what metrics are they looking at? Well, they're looking at how many demonstrations or experiments. This is when they take the technology that was funded by Peter and actually get it out to Marines in the field and have them use it. And even more important, and basically for testing, evaluation, things like that, they come down to Camp Roberts, to the NPS, run GIFIX down there quite often. And that's very good. And even more important than that is the number on the right, the transitions. These are how many of their programs actually make it out and are transitioned to being given to Marines in the field in an operational standpoint. And that's very good. It's very close to the warfighter. That's what the Office of Naval Research wants for its programs. We talked yesterday or the day before about how, I think Emory gave this in his brief, about how we can't be looking out nearly as far. We have to be looking much closer, i.e. what are we giving to the warfighter tomorrow, the day after tomorrow, next year. And so this is one of the things they're being measured by, but it's also a very academic endeavor. There's a lot of universities involved in this, a lot of people at Navy labs and that sort of thing. And even the people who are involved at contractors generally try to publish their stuff. So they had 30 papers and presentations in fiscal year 20 and 8 awards given for the research, best paper or the like as what was going out there. So it's kind of a neat milieu to be playing in because it works very closely. It's very similar to what we're trying to do here at MOVE, especially as we're moving to making sure that we're giving things to the warfighter and transitioning to them as we're going into that. But we still have to take, we have got one of our other foot in the academic world, and we're trying to serve the, both of those areas. And I think this does the same thing. So what is our approach here of the money that they fund us every year? We're in the third year of our funding. I anticipate that continuing after that. Peter seemed to be fairly pleased with what we do. Main thing we do is we support the student theses. And we do that in three main ways. The first way is we provide staff labor. So for those of you who know moves, know we've got a great group of programmers over in, run by Eric Johnson, and 5 or 6 guys now, and they do great stuff, but they can't work on student theses because they need to be paid out of reimbursable research. Well, we can use this money to pay them. In the past, when our curriculum was 8 quarters plus a refresher, there was technically time for somebody to build a system and do a full-scale test on it that actually, meets, high-level criteria that you can kind of stand up to an operations research type of analysis, other than just a quick, okay, I'm going to give somebody a Likert scale and do it. Unfortunately, with that quarter cut out, that's very, very difficult to do a real, training transfer test for something like that. So students who want to do that, we can actually have the staff, they'll come up with an idea, they'll give it to the staff, and the staff will build it out or modify something that they've done already to help them do their thesis. Likewise, we prefer to run experiments on Marines in the field, if possible, or sailors in the field. And we can support travel for primarily for experiment use, but sometimes if there's a conference that a student really wants to go to, we'll fund that. And we also provide equipment. So if somebody needs something, a special type of laptop, a head-mounted display, or something like that, we've bought that for them in the past. Conference attendance, kind of pulling this out. One conference we generally go to every year is the Inter-Service Industry Training, Simulation, and Education Conference, the week after Thanksgiving down at Orlando, Florida. We send our students out there. It's held virtually last year, so they attended virtually, but I think it's a great experience for them to get out there and go. We actually try to send them both years because we send them early, even though they're kind of, really got the deer in the headlights look. I mean, going to ITSEC for the first time is kind of like, a 6-year-old at Disneyland. There's a whole bunch of lights, a whole bunch of things flying around. You don't know really what's going on, and you get a little bit of idea. But we want them to go in their first year because a lot of them have gotten great ideas of things that they can use for their theses, either use for their theses or thesis ideas by attending ITSEC. And we still want to send them again in their second year because now they're a little bit more mature. They've had about, 15 months of M&S education under their belt by that time. And they can kind of go as a more informed consumer and kind of, ask the hard questions, look at some of these things, and they don't really kind of have the sense of awe as much as they're going. I think that's a very valuable thing to do. Besides, meeting everybody, these are pretty much everybody in the DoD modeling and simulation world goes to ITSEC. And so these are the peers that they're going to be working with out there in their jobs when they graduate and go to the fleet. Peter Squire has his HPT&E Tech Review twice a year. We normally send the students to the fall one. Peter's kind enough to, it's important enough to Peter, I guess, to say that he'll schedule his tech review to make sure it happens in the week between quarters so that NPS students can attend and not miss any classes. So, we really appreciate that. I think that's a great thing. And again, we try to send both our students out there from both cohorts because it's a great place for the junior cohort to get some thesis ideas. By the time of the tech review, the senior cohort pretty much have to have their thesis or proposal done to do that. It funds the Southern California trip. I'm going to talk a little bit more about that. And we also pay for alumni to attend the Moves open house when it's not being held virtually. So, next year, if we are actually holding it in Monterey, as we hope, we can fund some of our alumni to come here and kind of re-engage with Moves itself, other people in the field, and kind of go see what's going on back at the old alma mater and in other areas. So this is kind of how our battle rhythm works in the course of a year. Right now, and I'm going to start down here at this green one, where it says have HPT&E performers give VTC presentations. And that runs, you kind of see that runs from April to June. And in the 3923 class, the thesis prep class, we have quite a few class time that's given to, we set up VTCs with some of the performers that the students have the most interest in, and they come and brief their research. This year, it actually worked out even better because the spring tech review for Peter Squire was virtual and all the talks were recorded. So instead of having to like coordinate other people setting up a VTC, we're just playing the talks that kind of have the most interest to the students. And that gives them a good idea for some of their work that they can do on their theses. In July of that year, the students will submit their funding requests on what their thesis, they'll tell us what they're planning on for their thesis and what type of funding they will require to do that. And so then we make our decisions for the next year based upon that. As I said, we attend the fall tech review in September, and the students turn in their thesis proposals also in September. Jump up to the next fiscal year, from October to December, we generally get about 16 man weeks of Eric's team to work on support building thesis projects out there. And so this is when they do that. So they kind of have to have, in the beginning of the fiscal year, they have to know what they want to do. And we fund Eric's team that way. That works out nicely for him because quite often, you know, money is not always here for the new fiscal year on October 1st. And whereas this money is calendar year money, so we can basically just give it to him at that time. He can continue his team working over that time and keep working that way. It's sick, as I said, the last week in December, or excuse me, the week after Thanksgiving is a better way to put it. First week in December, we send people, students out to that, and we start buying equipment for the theses, research over that. Generally, we'll fund their thesis trips in January, February, March timeframe. Sometime around February, March, we have the current operations trip, which I'll talk about in one slide. And then we come back to the open house, then we start all over again. So that's really kind of how the program works for most of the year. Southern California trip, I said, wow, you know, you're going to Southern California, you're hitting Disneyland. You know, we don't hit Disneyland, we hit places that are even better. MTC at Fort Irwin. That's a great place to go out there and hit that. That's really the, you know, you've heard live, virtual, and constructive. That's probably the place where the U.S. military does live, virtual, constructive the best on a recurring standard. They bring in 10 brigades a year, every month except December, for they have a Christmas break, and July that they bring them in for so people can transfer. And also it's pretty darn hot down there in July. So we go down there and we see their live, virtual, constructive operation. And it's a great time because it really gives everybody the hands-on experience of seeing all the things they've been learning. You know, what Chris and Don have been teaching them about networking, about all the different systems that way, all the different things they've been learning from IMRA about simulations, some of the virtual stuff they get from AMOLA, you know, some of the training stuff they get in my class, you know, the AI that they use there from Chris Darkin, all that kind of stuff comes together at NTC to see how it's used. We go to the Marine Corps Air Ground Combat Center at 29 Palms down there because most of our students are Marines. So we'll go down there and see that. And unfortunately, the Marine Corps generally doesn't have quite the equipment that the Army does. So it's kind of a wake-up call to the Marines. You know, a lot of them have gone through there as you know, Marines, you know, combat units getting trained there. But it's kind of we go there, we go to the Battle Sim Center, which one of our graduates is the head of, currently Major Aaron Demschko, McTogg and McLog, the Marine Corps Tactical Operations Group and Logistics Operation Group, where we got two other graduates, Captain Colton Fedoroff and Captain Thomas Schutt are both down there right now. So we can get that, and they kind of see that. And then we generally try to stop by at the USC Institute for Creative Technologies. And that's when, because they do some great work down there. It's all military folks. So we see what some of the greatest of the latest of the new stuff coming up is. So that slide wasn't supposed to be in there. So we're going to talk about some of our recent student support. We funded 18 theses in this, including 4 that you've been briefed on yesterday or the day before. Alex White, Bill Mahan, Chris Garibay, and Max Schlessel. We have another student who was unable to brief, but Shane Robinette is basically coming up to train platoon leaders in how to basically put their platoon into a formation. We had a naval officer who did an AR technology for basically figuring out whether or not zone inspections, if you've ever been involved in those on a ship, or other maintenance issues, whether or not it's easier to figure out if there's a problem or where the problem is or what the problem is, using augmented reality versus using the current version of the CSMP. 6 more, in the previous years. I'm not going to go into all of these because we're running a little bit late. One thing to note, Dan Yurkovich's did, if you saw this, if you read the Marine Corps Times, they actually had an article there. This is my robot. There are many like it, but this one is mine. That quoted Dan at great work and talked at great length, and talked about his research. Garrett Laufman's work is actually continuing on right now. SPEMS, the Scaled Performance Evaluation Measurement System, has been briefed to the Commandant, and it's basically a more graduated replacement for the PECL system, and this one got a lot of awards also. Chris Angelopoulos' work also got followed on with a lot of augmented reality work, and other people that we've worked on too, going back further and further. So 15 theses from 2015 to 2016, but as you can see, there are 6 this year. We're starting to support more and more of the thesis. It's kind of the funding has increased in recent years a little bit, the last 3, as well as the fact that we've had more funding because we haven't had to travel in the last year due to COVID. So I guess that was one good thing that did come out of COVID. We've got 9 conference papers and presentations based upon the work at those 4 conferences you can see there. 3 conference posters, a book chapter, a couple of technical reports have come out of it. So, this is good work that's going to peer-reviewed sessions and getting out there, into the academic world, as well as a lot of, as you can see with SPEMS and the augmented reality work that's continued on. It is being done also for the military, so it's being followed on that way. So, and hopefully some of these theses that you saw, this week will actually be continued on and actually make it out to the fleet and make a difference there too. A lot of different awards that we've earned, several great awards here. Very proud of, how well our students have done. I think we've got at least 4 or 5 students who've been funded or graduated with distinction based on this. And I mentioned Captain Lofelman's thesis and Commander Angelopoulos' thesis. And also quite a lot of this research has been briefed out there to a lot of different people. The Sergeant Major of the Marine Corps was here just a few months ago and was briefed by students who are being funded by the ONR funding. And you can see here that, once again, it's all focusing on our graduates. So this is the cohort that graduated. I think that is 19, if I remember correctly. So it's good to see those guys and ladies out there. And this kind of says some of the things I've said. I'm not going to have time for the video on the 3D Warfighter augmented reality. I will put it out if you request the slides. Probably won't be in the slide deck, but I'll include it with that and zip it up. So that concludes my presentation. I was wondering if anybody had any questions on this. Okay, good. Well, thank you very much. I really appreciate it. And now you can tell that, I was going to put this together because you always want to make sure you got a good speaker after you. So hopefully some people will come and see you speak, get there early to see his talk. So we're very lucky to have Chris Fitzpatrick. He'll be briefing us on, a lot of great work that's been done. One thing you may not mention, but I want to throw out is that you've heard a lot of the students and other faculty members talk about the VPN that kind of has allowed them to do the, continue to do work in hooking together different systems in the lab. That's a very important part of our educational education here at Moves. And Chris was really the guy who made that happen. So he did a lot of the hard work, the grunt work on that. ITACS played a part in it, but I think he was the one who was really kind of heading that on Moves. So, thanks to him for that. And I think a lot of the things when he sees presentation, I think a lot of that work will kind of, you'll be able to see how well he's done on that. So Chris, do you want to go ahead and start sharing?
Yes, thanks. Hey, thanks, Perry, for that kind introduction. I really appreciate that, and also for the opportunity to talk today. So this is kind of exciting for me to, express some of the or to talk about some of the things that the students have done and how we're kind of building out our LVC program here at Moves. So I'll go ahead and share my screen. Okay, thanks again for the opportunity, and we've kind of done our introduction. But I want to quickly talk about how we understand LVC at Moves. This is just kind of foundational before I get into some of the research that was done and kind of what our vision is, our approach, and what we're looking to do. So obviously, live simulations involve real people and real systems, and they're considered simulations because you're going against a simulated red force entity in this case. So that's live, and that's our goal. Is in the Moves department, we're thinking about I think really the hard problem in LVC is going from virtual and constructive to live, and that's what we're trying to do. And you'll see that there's a thread in some of our research that goes through that. Virtual is basically involves real people operating simulated systems, and then you'll see in some of our research we use some flight simulators where we have actual qualified pilots come in and fly some CAS missions for us within designed experiments that we have looking at exercises. So that's a one area for virtual that we're looking at. And then constructive is simulated people operating simulated systems. So you have computer generated forces that are executing behaviors, and I think what's interesting about that is following on from Chris Darkin's talk is looking at those simulated entities actually doing intelligent behaviors that are autonomous. So that's an area that we might potentially be looking at in FY22. So next slide. Okay, so our research approach to LVC at Moves is really we're taking a bottom-up approach to doing this. One of the things that I've noticed as I've kind of gone out into the LVC community is I go and I see large-scale exercises. I go down to Tactical Training Group Pacific, and it's mostly large force exercises that are looking at command and control, decision-making for stabs, et cetera. And what we're trying to do is maybe look at that squad or small unit level. And in doing that, we feel like at some point we'll meet to those larger scale LVC exercises, and that we could potentially, create opportunities for, getting that virtual constructive to live with small units and squads and things along that line. So one of the things that I think we've kind of heard through these talks is that our best ideas come from our students. And so one of our students in 2018, and he actually was from the IS department. He stopped by my office. I was just in there doing some research, and then so he came by and wanted to talk to me about an idea he had that he thought was a little bit more intense than a thesis, and he wasn't able to do it. And what he was thinking about was this whole concept of using Android tablets to stimulate training for small units in the field. So he actually was coming from the Marine Aviation Tactical Simulation Systems Command out at Camp Pendleton, and they're doing quite a bit of work with call for fire training and integrating, the Direct Air Support Center, one of the C2 units that manages airspace for, fire support exercises. And he thought that, there are ways to use constructive simulations to kind of stimulate those environments and create something exciting that would, stress out the squads and cause them to need to make decisions and actually go against a dynamic red force. So we kind of took that idea and kind of ran with it. So I'll get into that a little bit later, but this is actually our vision for our LVC research. Again, looking at that Android virtual environments for live training and using those Android devices is getting what we have in our LVC Interoperability Lab, all those constructive simulations and image generators that we have, and getting those out to the field. So that's my goal is we have our lab on campus where we have our VPN. We're also looking at getting on AWS putting some of the simulations that we do have in that environment so that we can, run them on the cloud, run them on the VPN, and then maybe even run them on the closed network that we have in our lab. So what my goal is to get all these simulations out to handheld C2 systems and then desktop applications for staff training. So in doing theses, Captain Lauren McCann completed a thesis in 2020 looking at the GoTenna RF mesh radio, and I'm going to describe that work in a little bit of detail because that's kind of a foundational effort to our LVC work. And what she was looking at doing was transferring that simulation data over an RF mesh network to get to those Android tablets. And then in addition, we've looked at the tactical services oriented architecture over to the left and getting those desktop C2 systems stimulated with DIS data. And that's again, something that will allow our C2 staffs to kind of drive what squads are doing out in the field. So all of this, as Imre had talked about, was funded by TCOM in 2018, and it was something that me being a former student at MOVES, I always I wanted to see the latest and greatest that were out there in simulations. So what we've done is put together all these simulations so students have access to them. And you saw how Alex White was able to use MACE, and then he also used VBS4 in his thesis. Chris Garibay used VR Forces as well as Bernd Weissenberger. So they both used that simulation. So we're seeing that students are actually kind of getting to that point where they're picking and choosing what they want to do based on what their thesis research questions are, and seeing what are the best simulations to use for that, and creating that conceptual model of what they actually want to do. So that's where I have that modeling and simulation as a service. That's something that we're kind of thinking about for our LVC research, is as units want to do some training, what are the best options for them to kind of execute that training. So for example, and when Alex talked about his thesis and doing supporting arms, MACE is something that's really good to do that. It's something that the Air Force uses for close air support, but also artillery, 81 millimeter mortars, and actually the user interface is very similar to what a joint fires observer or a FIS team member might actually see out in the field. So I just kind of wanted to point that out, that we're looking at along those lines. So our LVC research roadmap, one of the things that I wanted to kind of talk about is where we're going with our LVC research. So stimulating C2 systems, we're already kind of complete with that work, and that's something that we're definitely able to do, and we're finally in a position where we feel like we're ready to move forward. So we did that, and in FY20 we looked at those RF mesh networks, and that was pulling that data, putting it onto small packets that could be received by both C2 systems and maybe other simulations. And then the next step in FY21, and this is what you can see with exercise design, and that's kind of where Alex and Chris Garibay, their theses, looked at that. Alex looking at the, calls for fire, and Chris looking at EABO. And in those two areas, we kind of focused on, what do the warfighters actually want to do. And then in 22 and 23, we're kind of looking at, potentially using AR devices, and then going from live to virtual and constructive. So those are the two areas. But one of the things that I wanted to point out was Bernd Weissenberger. He actually did a final project in my class, MV4503, Advanced Simulation Interoperability Networking, where he actually pulled out detonation packets and was able to create an immersive environment where he would pull in the packets and create a sound effect for blasts or things along that line that we actually saw in the simulation. So what I thought was interesting about that, and when Bert talked to me about it, his wife kind of liked that project, so she was hearing all the detonations as they were going on, and he was testing them with the simulation. So I I think we're, doing some research, bringing it home because we're in the COVID environment, and it kind of fosters that a good relationship with with your wife. So just want to throw out a little joke there. So okay, so. Again, how do we get there? We kind of talked about that, a little bit, but I just wanted to mention. So we talked about Alex, Burns, and Chris, how they kind of, supported this vision for moving forward in LVC, but also Captain Max Schleschel, who you saw brief, as well as Captain Ryan Somm, they're doing the same thing. So this LVC interoperability lab that we're creating, and we're kind of on a good path towards doing that, is helping us do experimentation. And that's one of the things that Max had done. And you saw that he went out to second LAR and was looking at, different, human responses to increased stress using simulation environments. So I think, that's something that we also saw in Alex's thesis, where he, integrated DIS voice into that. And I got a chance to participate. My stress level went up, because I had to, I had a role in the exercise. And I think that's something that we'd like to do is maybe continue to test and experiment in that area. And the LVC Interoperability Lab allows us to do that. Same thing with, Captain Somm, and he talked about using the systems toolkit, as well as having that stimulated by VR forces to get that, those mission profiles for that combat information or data of what was actually going on, and looking at mission profiles for how UAVs were going to sense and detect those different areas. So again, I look at this as this LVC Interoperability Lab is allowing us to have modeling and simulation as a service. Ryan had a problem that he wanted to solve. He's looking at developing requirements, and then he was able to go to our lab and look at the different systems that were available to do that, and build requirements for the Scan Eagle. So again, our work is very, very much so based on our students and what they're doing. So the foundational research for Anvil, I just wanted to kind of go back to that, because it's primary to this work. But one of the things that I wanted to mention is that we're thinking about a conceptual ready room where we can actually stimulate C2 systems before guys actually go out for a specific mission, and they can look at what a dynamic red force might actually do. And so Amla had mentioned one of Bert Knobloch had done a thesis using a head-mounted display, looking at a geographic area and moving around entities within that area. So that's something in that conceptual ready room diagram. You could see there's three gentlemen in the back looking at kind of an environment with a head-mounted display. And I think that would be interesting. In a conceptual ready room of the future, guys could be putting on head-mounted displays and actually looking at different simulations, stimulating forces moving around, so they can talk about decisions and seeing it happen real time, and really prep for what's actually going to occur out on that training mission, so they could have better training transfer. Additionally, the other concept with Anvil that Lieutenant Colonel Clark had kind of pushed for was that the use of Android tablets within aircraft, and so that you could have this concept of tablets on the dashboard. And that's something that we've kind of been pushing forward. And you can see we have a FLIR up to the top right, and then also on the bottom right we have an ANAPR 39 that's actually we've built an application that stimulates an Android tablet that has that operating has an ANAPR 39 operating on it, that's stimulated by a constructive simulation, and shows different surface-to-air missile threats that a aircraft may have to evade or move around from or fly a different mission profile. So again, this Anvil, kind of feeds into some of our next areas. So the other thing that when we talk about trying to build LVC from what's already the warfighter's already holding, we looked at these GO-10 radios, and this was an idea that we got from the first EOD company down at Camp Pendleton, and they were using these GO-10 radios to pass images of say bombs or explosives that they would see out in the field, and they would be sending that back to their command and control centers to see, hey, what should we actually do, or what should we how should we move forward? So what we thought is, hey, why don't we try to put some simulation data on that network, or can we actually do it? So when we look at the specific radio, the first thing I wanted to point out is the payload size. The payload size of the GO-10 radios is 235 bytes max that they could actually pass. So that's something that would be, obviously restrictive for us. So one of the things and actually I want to point out, Kirk Stork had done a lot of the programming for this work, is he looked at DIS data, what comes in DIS packets, and then he also looked at how does the GO-10 radio actually pass its data, and then also looked at moving from how the GO-10 radio passes its data into how can we convert that data into something that can be seen by an Android tablet. So that's, again, our we wanted to kind of use what's already being held to kind of create our LVC environments. And you can see by the specs on this radio that we'd be able to do a pretty realistic distributed exercise, and so that's something that we're moving forward with. So the next few slides we'll talk about kind of our progress there. So our research objective, for expanding Anvil, for expanding Lieutenant Colonel Clark's ideas, was getting it out to distributed networks using the GO-10 radio. So what we wanted to do was to, broadcast location data from entities and simulations. And then also, one of the things that the GO-10 radios are used for is for units that are jumping out of aircraft. They use it for, specifically putting location, like, hey, where did guys land after jumping out of a C-130 or an MB-22 or something like that. So in looking at that, we wanted to be able to pass that live data back to our constructive simulations. So that's our second kind of research objective. And then we wanted to display all of that data onto C2 systems. So that was primarily what we were thinking. So this is just some operational pictures. Move through this quickly because I've kind of explained this, but just wanted to let you could see that these GO-10 radios are tiny. They can just actually go onto a backpack, and guys can have them in the field. And so that's why it's like we need to leverage that, and that's kind of what we were thinking. So the guys are already holding the Android C2 devices, and in that case, that's an ATAC, which is an Android Tactical Awareness Kit, and primarily that's what Bernd used for his thesis. And you can see the GO-10 radio there, just to give you an idea of what the size is. It's very tiny. So our conceptual system overview was our constructive simulation. That obviously was passing DIS UDP datagrams to a gateway application that we had running on that same laptop. But that gateway application would parse that DIS data into a format understood by a USB connected GO-10 radio. That information would be passed over the air to a Bluetooth connected GO-10 radio connected to an Android tablet. On the Android tablet, what Kirk had built was an application that parsed the GO-10 datagram packets into into a COT package, which is a cursor on target schema. And it's a schema that's been around for a long time, but it's something we teach in our MV 4503 class as a way, or as a way for the students to, to get some exposure to XML, and then also learn, about, tactical schemas and how they're used, and what they're, and in the class, they actually, like Kirk did, built an application or build an application that parses data into that COT schema, and then it goes onto a display. So this is our conceptual system overview, which we have built out. And then and here just gives you a quick view of that of what that gateway program looks like. And you can see in that middle part there, basically it pulls in that GoTenna message, and then there is what the cursor on target schema looks like. And it pulls out all that information, so that, that type is something that's in the MIL standard 2525 symbology that, says what, a specific entity would be on a C2 system. So it's, you have A is atomic, H is hostile, A is for airborne, and then MFUM is some type of a UAV system. I think it's like a type or like kind of a middle-sized UAV system. And then you can see, you have your start time, your stale time, and then your latitude, longitude, circular error, height above ellipsoid, and then linear error that is all passed. And once that's passed the ATAC, it displays the icon on the screen. So here's just an actual test system that we built out for Captain McCann's thesis. And there you can see the GoTenna transmitting. You can see the one receiving down on the bottom right. And that's VR Forces just with a small little tactical scenario that we had built out for that. So again, you can see that we're to the point in our LVC research where we're, starting to simulate C2 systems in distributed environments. So that's something that we're making good progress and we're moving down a good path. So we're not completely doing all interoperability research. Some other projects that I'm contributing to is the Grill Summer Research Challenge. So I want to talk about some of these programs. Contingent Attention Management, we're doing an experiment with NRL. On that program. Living Laboratory, little does Major White know that actually some of his thesis work we've kind of pushed forward to PMA 276 as a potential to build out a laboratory to build requirements for the future vertical lift. And then we're also doing Coalition Warfare Integration Exercise 2021, and we're looking at NPS hosting the mock RTI and then also the pitch RTI. In order to connect simulations together and run the scenarios. So first to talk a little bit about the Grill Summer Research Challenge. The Grill is the Gaming Research Integration for Learning Laboratory. It's at the Air Force Research Lab in Dayton, Ohio, and we have a good relationship with them because I do a lot of interoperability testing with them, running Prepared 3D, Lockheed Martin's flight simulator, and also some other constructive sims where we do distributed exercises together and do some practice there on exercise design. But one of the things that we did last year was we submitted a proposal to potentially help out veterans suffering from TBI and polytrauma. And one of the things that we wanted to do is look at using AR and VR technologies in order to help them deal with their some of the issues that they're dealing with and help them to integrate back into society. So to our knowledge, this is the first time that AR and VR have been used to assist with veterans. And so right now we're working, since we built a lot of our applications in the Unreal Engine, we're working with Epic Games and looking at submitting a Mega Devs grant. So we've made some progress and we feel like we're ready to kind of move forward and do experimentation. And so we're partnering with Stanford University and Stanford Medical Center VA, the Air Force Research Lab, or the Grill, and then us. We're looking at potentially building this out a little bit further, in the next year. And what I wanted to kind of show you is that we're looking at helping or using AR and VR to help our veterans with navigating, around their home, around the local area, looking at maybe doing cognitive exercises with them if they're suffering from, say, dementia or other issues with basic learning, looking at a medication administration in their home, and we want to make sure that they're able to actually administer the correct amount and type of medication while they're, recovering at home. Meal preparation, some safety precautions as using the stove and then hygiene, and then also lifestyle. So we're looking at hitting all of those areas, and so apologize. So one of the things that we've done is through that summer research challenge, we built out a smart room that's at the VA that's being used to treat VA's patients with traumatic brain injuries. So that's something that, and then we started to build some applications in there that are specific to some of these, treatment areas. And we feel like we're ready to show Epic Games what we can do. And so I'm working with Dr. Quinn Kennedy on that one. And we're looking for, a three-week program to kind of push this work forward. So one of the things where networking might be, applicable to this is having some of those veterans with TBI maybe interacting with their clinicians and working with their doctors via network. So we're certainly thinking and looking at that as we move forward with this project. So I know I'm getting close on time, so I've got about 3 minutes. So this contingent attention management, basically what we're looking at is helping out Navy surface warfare watchstanders, and what we're trying to do is that they're overwhelmed with chats, voice communications, and so what they're finding, what NRL has found through this process, and they've asked us to kind of help them out with this, is to perform an experiment where we can actually have some of our surface warfare officers on campus kind of prioritize, different voice communications, chats, different tracks that are on, C2 systems, and put them into a position where they can do what's called serial multitasking, where they can actually be given, based on priorities, one thing to deal with at a time. And they want to see is, does performance get a little bit better if they do that? So the reason that NRL reached out to us is, one, our availability of surface warfare officer students, and then two is maybe using constructive simulations to kind of stimulate these environments to do future experimentation. So that's an area where we're happy to work with them, and so through this program, we've actually kind of started interacting with the Surface and Mine Warfare Development Center, and they've got a program called the Surface Warfare Combat Training Continuum that they're looking at, kind of building out training so that they can get a good cross section of surface warfare officers at different billets or different ships, across the fleet, and you have your best, your best quality spread of talent across the fleet. So they're looking at doing that. This is just a quick look at one of our experiment tools that we're using, and it's showing kind of that, kind of prioritizing, what's actually out there. So this is our surface warfare students are going through this and looking at prioritizing to help out with this contingent attention management program. And then finally, this is Alex had showed this, so I won't cover this at all, but this is that, that future vertical lift, looking at kind of, having that simulator, and then also kind of, trying to create requirements for the FVL, like looking at, different things, different ways to interact with the DASC or the Fire Support Coordination Center, things along that line. And we want to use simulations to do that, to build better requirements. And then finally, we're working on the virtual schoolhouse project, and this is one of the areas where what we're looking at is we're building out a capstone in FY21 to go end-to-end live virtual constructive. So you see we have X-Plane, that produces data for a virtual simulation that a pilot's actually flying. We can actually create that, push that over to Amy, and Amy can convert it to COT and DIS. COT will go to the Android Tactical or the Android Tactical Awareness Kit, and also DIS could go to NGTS. So this is one of the exercises. We do this in little bits and pieces in MB4503, and we haven't used Amy to do that. We kind of just used OpenDIS that Don manages to do some of that work. So our next the next thing that we're looking at doing is using Amy to do that. And Amy is the architecture management integration environment that's sponsored by NavAir. So that was a quick overview, and I think I went over by about a minute, but if anybody has any questions or, we're very excited about the direction we're going in LVC and how much the students are helping us do that. So I just wanted to, go ahead and point that out one last time. So thanks again for your time. I apologize for going over slightly.
Chris, no, thank you very much. That was really great. Really interesting work. Don's up in video, so I think, do you have anything you want to add, Don?
Yeah, please. Just thank you, Chris. It's the 2-course sequence for entry-level networking simulation and the advanced networking simulation that you're teaching. Seems like we really have a drumbeat going, and it's enabling our students to get to these levels in all of these directions that you showed. And it's so totally impressive to see all the connections that you've been able to stitch together and sustain. It's also interesting that, it's getting more and more about the data. We always got to get that network connection and the protocols, but it seems like our focus in the classes keep growing on data. I wondered if that matched your impressions and forecast or what?
No, I agree. It's definitely a huge environment, and that's why I think it's good that we're starting from kind of the bottom up. I like that better because it opens up opportunities for student theses, and it's easier to kind of do things that we can in a research lab. So to me, I think we're almost kind of forced into that that domain to kind of work at the smaller unit, but it's I think there's a need for that. So
Excellent. No, sounds good. Anybody else have any questions? Okay. Well, thank you very much, Chris. As Don said, that was a really great talk. We appreciate all the great work you've been doing here. That's awesome. And
thanks again for the opportunity.
Well, thank you very much. Just want to thank everybody who is here, part of it. Thank everybody who presented this week and has made the Moves Open House work well. And just remember a few things. If you are interested in getting a copy of the slides, please email me, McDowell, McDowell, at nps.edu, and I'll make sure you get them. Also, the videos will be available on the NPS YouTube page sometime next week. I should be getting them over to the PAO tomorrow. I have to do some processing on them. And Monday's a holiday, and you probably won't get too much done. So hopefully middle of next week, they'll be up on the NPS YouTube page. I will send a reminder out to everybody on the email list when they get up there. And that's it. Does anybody have any final comments? Okay, well, thank you very much. And hopefully next year in Monterey.